Hello. Wait, I'm all by myself.
Hello.
Oh, wait, no, I'm not.
Electron configuration.
Oh, good. This is part of the tile on our periodic table.
Absolutely. How these electrons are arranged around an atom is kind of a big deal.
True, and I need to know how many of them there is and where them all at.
Yeah, it's kind of like you got to know where your cattle is. It's all timed out in the lower pasture, the upper pasture. How many is there? How many got away? Okay.
Exactly. You got that? Oh, who's counted their cattle lately? Just rain.
You haven't?
I don't know.
What?
I don't know if I can continue with this video, but I'm gonna try.
You're gonna do it.
Oh, boy.
You're gonna do it.
I bet we're gonna start with.
Learning targets. Yeah. These important messages. I can.
It's like an advertisement.
The more you know.
I can explain how electrons are arranged around an atom or an ion.
Sweet.
Boom.
Electron configuration of ground state atoms. The number of electrons in each energy level filled, specifically 2, then 8, and then 8, and then 8, and then 8.
Mhm.
We'll see some deviations, but we're not going to go into why. Let's go with it.
Packing electrons around atoms follows a pattern, is what
Yes.
Mr. Milk's saying. The valence electron. Oh, this is not my turn.
It
Are
is.
we going backwards?
Did. You are quick.
Valence
Anything
electrons.
by you.
No. Electrons in the outermost shell. These are the last in the electron configuration. So if you look at an atom, these pictures, F, fluorine, chlorine, bromine, iodine, the outermost, the furthest out shell is the valence shell that I'm talking about, and it has the valence electrons.
Right.
Coincidentally, all 4 of these elements have the same number of valence electrons, which will lead to something later on
It will.
about how they behave when they're mixed with other elements.
Yep. And if you don't have a picture, like he said, he's not lying. The last number, not the first number, the last number is the number of valence electrons.
Mhm.
We will need that. Whoopsies. The kernel is all of the internal electrons. So if you're not a valence electron, you're a kernel electron. It's just that simple. Add up all the rest of them and you got it.
They're the inside ones. Like kernels are on the inside of popcorn. It's all kernel.
Isoelectronic has to do with the electrons. So if you lose some or you gain some, it's going to have the same configuration as some other element when it's at its ground state. When it's
Exactly.
When it's not an ion.
Mhm.
We will find that ions like to become a noble gas.
Isoelectronic with a noble gas. Because that is very stable. Electron configurations for ions, we always start with the electron configuration for the atom, and then we've added or removed electrons from the valence shell. So if I add electrons to it, it's going to get bigger, and we have to show that there's another electron in that outside shell and a negative charge for the ion. If I take an electron away from it, that usually gets a little smaller, and we have a gap missing and a positive charge for our ion in the top right corner.
Right. Point being, we only take from that last number or add to that last number, never in the middle.
Yeah, we can't steal an electron from the middle because they're being protected by all the other ones.
That's right. Now, an excited state atom's electron configuration varies from the normal pattern of 2, 8, 8, 8. So if I see 2, 7, 8, there's a deviation.
Yeah.
It should be 2, 8 first before I put anything in the third.
Right.
The first 10 should go 2, 8, and then start filling it.
I just thought of something.
All right, go ahead.
A ground state atom is like a hotel that says no vacancy.
Right. Oh,
Every single room is filled with the maximum occupants.
yeah, parking garage.
An
full.
excited state electron configuration is like a hotel or a motel that has that sign flashing vacancy, meaning there's an empty spot somewhere in that atom that could be filled up that's not the outside shell.
Right, and what's happened there is energy's been given to that atom, and the energy goes into that electron, and it jumps up to a different orbital,
Mhm.
and then you can see that it's in a different, or orbital is another word for, those circles.
Ooh, this fun. I got to figure out a table ready to rock.
Oh, you do? Who's
Yeah.
drawing?
Who's right, guy? Who wants to write? You want to write, Yunar?
Yeah.
Ooh,
Cool.
Here we go.
So here we go. We got an electron configuration, substance sodium. The electron configuration for sodium, 281 is what I know to be the truth. Is this an atom or an ion, you think, Yunar?
Looks like that's the same number of electrons that it shows on the periodic table, so it's got to be an atom.
Atom. And since they're in the normal filling pattern of 2, then 8, then something else,
Ground state.
ground state.
No vacancies.
No vacancies.
Okay, next piece, I'm going to give you a different, right? I'm going to give you something different.
Ooh, 2873.
All right, so now to figure out what this is, let's add them all up. So 2 and 8 is 10, 7 and 3 is 10. So that's 20 electrons. 20 electrons means 20 protons.
Yes.
Who has 20 protons?
Calcium.
Calcium,
Ca. Calcium.
Okay, good. And is this an atom or an ion? It's actually an atom.
Atomos. Yep. And is this in the normal filling pattern of 2, 8, 8 something, or is this out of the ordinary?
8, 7.
3. So there's a vacancy somewhere in there. So we're going to call that the excited state. How exciting. Next,
Next one up.
Cl with a -1 in the top right corner. Ooh.
All right, well, what's the configuration for chlorine?
Well, for chlorine is 287, but that's the atom.
Let's
that's
start
neutral.
there. Let's write it.
The neutral atom is
287,
287, and we've added one more electron, so we'll do 2, 8, 8, because we've added one more electron, -1, to this atom to make it an ion.
There we go.
We know it's an ion because the top right corner's got that -1. And how about that excited or ground state? It looks like the standard pattern.
Yeah,
Any
it's-
vacancies, Milks?
I see no vacancies. It's not 2, 7, 8.
Yeah,
Okay?
Right.
But the key part is we didn't write the 287, which is the ground or the normal thing.
because we slapped that extra electron into the valence shell.
I just want to make sure that because it's our first time through actually doing it, that we added to the third valence shell.
Mm-hmm. We
Okay.
can't do 297. It wouldn't work.
Okay.
286.
Ooh, how many total electrons? I count 16.
And if it's 16 electrons, we're going to go with 16 protons. So that'd be sulfur. SULFUR.
Good. And that's going to be just an atom.
Yep. We can't really tell if we're going after something else here. So we're going to say it's an atom.
And it's normal filling pattern, no vacancies.
Ground state.
You guys getting the hang of this yet?
For shizzy.
I like it.
Ooh, and a +1.
All right.
So sodium has a normal electron configuration of 281.
Write the whole thing, please.
But we have lost one electron from this
So should
atom.
I take it from the 2 or the 8 or the 1?
You need to take it from the outside.
See?
So the 1 disappears.
There we go.
So it becomes 2-8.
Excellent.
Atom or ion, Yunar?
Ion.
And we know because there is a charge in the upper right-hand corner,
Bingo.
and we'll call this ground state otherwise because our filling order is a normal.
Ground. Boom.
Good.
Calibration.
2,
Yeah.
6, 7, 8.
6 plus 8. 6 plus 2 is 8 plus 7 is
15.
15 thing.
15. Who that?
Phosphorus.
Phosphorus with a
With a
P.
pH.
Mhm.
Phosphorus. 2 pHs. Phosphorus.
Yes, but it's
2,
not the F.
6, 7. We can't tell if it's an atom
No, or an ion.
or an ion, so we're going to stick with atom.
Yep. There's no evidence that there's a charge,
Right.
so it has to be an atom. But ooh,
What is it? Excited or ground?
that number
They're
should
circling.
be
They're circling it.
there should be an 8.
6.
So in this
What
case,
is it?
2 electrons moved up.
Hmm.
Yeah, so it is
Which is
excited.
possible.
It is possible. You give it enough energy, it could happen.
Magnesium.
Yep. Mg magnesium. What is my electron configuration?
2-8-2.
And I have no charges, so I'm not going to add or take anything away. So it's
Yep.
an atom. And the filling order is normal, so it is
It's the ground state electron configuration.
beautiful. And did we just fill out this whole chart?
I think we did, Ski.
I think, is there more practice on this, I hope?
I hope so. You find out by looking in your packet and see if there's any you-dos.
And I think that you can do it
Hmm.
by following our example. And I got my fingers crossed.
Are we done? Yes. I clicked the button. I turned it off.
Rest in peace.